Okay. Looks like it's gonna be easy today. Binary prefix divisible by 5. You're given an integer, a binary array nums, 0 indexed. We define x sub I as the number whose binary representation is the subarray nums from 0 to I. Okay. For example, nums, if the nums array is 1, 0, 1, x sub 1 is just 1, x sub 0 is just 1, x sub 1 is the first 2, so it's going to be 1, 2 as a binary number, that's 2. And x sub 2 is going to be all 3, so the binary number is 5. Return an array of booleans answer where answer of I is true if x of I is divisible by 5. Okay. Straightforward enough. I think the key understanding is if you have a binary number, when you have an extra bit, the extra bit would make the other bits move down or move up, or however you want to think about it, have a higher bit value, which doubles the value. So 1 doubles to 2 when you add another bit, 2 doubles to 4 when you add another bit, and then the 4 is added with an extra bit of 1, so that's how you get 5 here. So pretty straightforward to just create a running value for the current for index for 0 to the current index, and then keep track of that, whether or not that value is divisible by 5. So let's say answer array. So for the current value is going to be 0. For every bit in the bit array of nums, when you value doubles, as you have one more bit, the value plus equals to whatever that bit is, and then answer appends whether or not this bit is divisible by 5. So bit mod 5 equals 0 is that. Return the answer array. Okay, I think that should be it. Wait, oh, really? Oh, what's going on here? Return Boolean array where answer of I is true if x of I is divisible by 5. Divisible by 5 means the remainder of it divided by 5 is 0. Huh, what's going on? Why would there be an incorrect answer here? Give me 0. 0, 1. Oh, ice. No, that's right. 0. So 1, 2, 3. 3 times 2 is 6. 6 plus 1 is 13. 13 times 2 is 26. Plus 1 is 27. But is this not 27? Wait. What? This is 2. So 1 doubles 2 plus 1 is 3. 3 times 2 is 6. Plus 1 is 7. 7 times 2 is 14. Plus 1 is 15. Somehow. Okay, let me go ahead and just print out the values here. Alright, let's go ahead and peek into what the values is being calculated as. So it's 15. Somehow output is false. Should have been true. Am I doing this division correctly? It's not bit, it's the fucking value. Oh my god, that's so bad. Oh my god, that was so bad. Should have been a layup. Okay. I don't see how this could have been that much faster. Oh, I guess I could just have done this in one operation. Yeah. Value equals value times 2 plus bit. I think this has to be the shortest I can do it. Oh, what the heck? Answer is an empty array, value is 0, for every bit in nums. The value times 2 plus the bit. There has to be some random variation here. Why would this not be fast enough for... This just cannot possibly be. What the hell? "22 milliseconds versus... Okay, there's something that they're doing that I'm not doing. I wonder. 111, false, false, false. I wonder if there's another way of detecting whether or not something is divisible by 5. Or, oh, the num's length is pretty damn long. It's 10 to the 5th. The value might be getting very large. Yeah, okay. I think I could probably do a modulo to make it smaller. Modulo 5? I think it might be modulo 5, so let's go ahead and do like 1 times, say 1 times 2 plus 1 is going to be 3. 6 times 2 plus 1 is going to be 13. Yeah, I think it's going to be mod 5 here, because I think they should be equivalent calculation wise. Okay. Alright, that was interesting. I was pretty sure that I was fast enough, but I guess I didn't pay close enough attention to the size of values that could be obtained during the calculation. Okay, so summary. So so understanding basics of binary values and place values helps with the calculation of the current value based on the index as a binary number adds an extra bit. The value doubles from its previous. So for example, if you have a binary number that is 1, 0, which is equivalent to 2 in decimal. if that becomes binary number 100, if you add another bit, that becomes 4 in decimal. Or something like B11 or B101, which is 4 plus 1, which is 5, becomes B1010, which becomes 10. So iterate over the bits in the array and recalculate the value based on the current bit. Well, the previous is the value is equal to the previous value times 2 plus the current bit. Append to an answer array after determining if that value is divisible by 5, i.e. the value mod 5, remainder of the value divided by 5 is 0. Lastly, note that the bit array can be up to 10 to the 5th in length, so value can, in theory, get to 2 to the power of, that 10 to the 5th. Thus, to make calculations faster, slash numbers smaller, use mod 5 post calculation to reduce the size of the values. So that was this extra little bit. Otherwise, it's going to get really slow. Time complexity is going to be O of n, as there is a for loop that iterates over every value in the bits array. Base complexity is O of 1, since no extra space is needed.